So far, we've worked with standard form when we're graphing. And standard form is shown here. You'd have it 2x squared plus 4x minus 6. And you would pick out your A, B, and C values. One of the other forms that we need to work with for graphing is factored form. And factored form, you can't easily pick out A, B, and C values. The only value that's quickly seen is the A value. So in factored form, you would have worked with this last year. We would have taken equations such as this one here, 2x squared plus 4x minus 6, and been asked to factor that. And then you would have came up with this equation here. The only difference from last year, this year, is that now we're graphing them. So it will be the y equals part. So we've already seen how to work with standard form. We'll do a factor form here and pick out the information of direction of opening, max and min values, width of the graph, the vertex, axis of symmetry, the y-intercept. So we'll do all that regular stuff here. So first step, let's look at direction of opening. So your A value here is bigger than 1. So this is your A value, and in this case it's bigger than 1. So for the direction, it's a positive value, so the graph has to point up. In terms of having a max or a min, this graph would have a minimum. Because it's positive, the graph will open up and you would have a minimum point. Vertex will be here, the curve is on the bottom. So we have direction, we have minimum. The width of the graph. Again, we look back at the A value, and where the A value is bigger than 1, the width of the graph is thinner. And this is a comparison back to the equation. So if you just have y equals x squared, this graph that we have will be thinner than y equals x squared. The axis of symmetry, over here, for standard form, we use the equation x equals negative b over 2a. We can't do that here. So first thing we're going to do, in order to find the axis of symmetry, we need to understand the x-intercepts. So we're going to build this idea. So this is something new. Start with that. This is new to you. So we have to get the x-intercepts. That's then going to allow us to get the axis of symmetry, and then we can get the vertex. For any graph, I should say for any graph that crosses the x-axis. So we'll draw a graph like this. The points where you cross the x-axis here, they're called x-intercepts. And remember, our grid is labeled x, y. So any quadratic that cuts through the x-axis will have x-intercepts. Not every graph will have them. If we drew a graph here, like that, you would cross the x-axis, so you wouldn't have any x-intercepts. So won't always be present. And for a graph that touches only at one point, let's say like this, you don't have one x-intercept. So I'm going to just erase these here out of the way. We don't need those muttering up the diagram. Okay. In any event, the case that we have here is that graph will cut through in two places. And the reason we know that is that we look back up here to our equation. This is the advantage of doing factored form. Factored form will give you your x-intercepts, and they're highlighted here. What you need to remember, though, is that these x-intercepts are always the opposite values. So our x-intercepts would be 1, so not negative 1 and 1. And wherever you cross the x-axis, your y value is 0. So whenever you cut through this x-axis here, your y value has to be 0. And our other x-intercept is going to be at negative 3 and 0. So what we have now, we've located where our graph will cut through the x-axis. So, and we know there's a minimum. We can have an idea now the graph will come down, cut through one point here, let's say at -3, and rise back up and cut through at 1. We need to find the location of our vertex. So our vertex, in order to get our vertex, we first need the axis symmetry. And the axis symmetry is a vertical line that we're drawing. We'll cut the graph into equal pieces. Now you could get that here from the graph. So if we had a nice scale for our x-axis here, we would just look for the middle between these 2 points. The other way of getting the middle between 2 points is to add the points together. So 1 plus -3 divided by 2. Again, just going to recap that. If your graph is drawn between your 2 x-intercepts, find the middle. That's where your axis symmetry will run up and down. If you don't have a graph, you take your 2 x-intercepts, add them together, and divide by 2. So 1 plus -3 is -2, divided by 2, and you have a value of -1. So our axis of symmetry is written as x equals. So we know our axis of symmetry in this case will be at -1. So we find our x-intercepts, we use that to help find our axis of symmetry, and then we find our vertex. Remember that your vertex, the x value, right here that goes in front, the x value, is the same as the axis of symmetry. So that would be -1. And now we need to find the y value. So in an equation, if you know one value, say in this case x, and you need to find the y value that goes here, substitute this value back into your original equation. So our original equation is y equals 2x minus 1, x plus 3. I'm going to just move my paper down. And now we'll substitute in our x value of -1. So anywhere we had x, we put in a -1 value. Do inside your brackets first. -1 subtract 1 is -2. And -1 plus 3 is a +2. 2 times 2 is 4, times 2 again is 8. Don't forget there's a negative. So your y value is -8. So for our vertex, we will have a value of -1 and -8. And that should be in brackets. So we find the width. We know there's a minimum, axis symmetry, vertex, and our y-intercept. So where does the graph cut through the y-axis? Whenever the graph cuts through the y-axis, the x value is 0. So if you think about your grid, or your plane, x, y, in order to cut through the y-axis here, your x value has to be 0. So substitute 0 back into your original equation. So it was x minus 1. Well, we're going to use 0 for x now. And 0 for 3. Sorry, not 0 for 3. But x plus 3, we use a 0 there. 0 minus 1 is -1. Let's not forget the 2. 0 plus 3 is 3. Do your multiplication, and you get -6. So what we know about a graph is our graph cuts through at -3, so we go 1, 2, 3, at -3, that's one x-intercept, and 1. The middle between these 2 points would be a -1 here. That's our axis of symmetry. We know that our graph has a vertex of -1, -8, and we cut through at -6 as a y-intercept. So this will allow you to sketch your graph. In terms of the domain, unless it's a story problem, the domain won't change. So your domain, your x value belong to the real. There are no restrictions. Could be any number. And for the range, your y values are greater than your lowest point. Your lowest point is here. So your y values have to be bigger than -8 or equal to. Okay, that covers off the information that you would need to know for graphing using vector form. So I have the worksheet completed for you, and the answer key will be posted. And the idea of this now is that you can ask your questions in class. Thank you.